Welcome back, students. Today in this session we are going to study about compound microscope. So compound microscope is one of the very important optical instruments as far as the exam perspective is concerned. So to begin with, what exactly is a compound microscope? It is a typical device that we use in our biological laboratory to view different specimens or different slides. So almost everybody would have seen it, or few might even used it. So what we will do is we will take a slide of a specimen and we will just place it under the microscope and we will slowly adjust the focal length of the microscope to focus the slide, and then through that I will be able to view the particular slide that I have placed underneath it. So this is the exact setup of a typical microscope, which is otherwise known as the compound microscope. You see, this is called as the objective lens, the lens that is under, which is close to the slide, and this is called as the eyepiece, which is close to our eyes. So this specimen, the light from this specimen enters into the objective lens, it gets refracted and it enters into the eyepiece, and then it refracts back to the eyes. So now let me tell you what exactly happens here. You see, this is a very small specimen that I have placed. The light from this enters into the first convex lens, whose aperture is very small and its focal length is also very small. So the objective length has a very small focal length as well as the small aperture. So the light from the object enters to this convex lens and then it gets refracted from there. It gets refracted from there. It enters into the second convex lens. It enters into the second convex lens, gets refracted from here, and the image is formed at infinity. So first what you have to realize is, this being an object and this H prime is the image of the object H, and then this image serves as the object for the second convex lens. Okay, and this image will again be erected. It will be erected when you view it through the eyes. So this is the whole thing that is going to happen, and if you observe very closely, I said that my image is going to form at infinity, but that image will be very enlarged or very magnified. You see, this is the size of the object and this is the size of the image that I am going to see through my eyepiece. See, it is multiple times greater. In fact, it is close to 800 times greater. Okay, the image gets magnified close to 800 times when you see it through the compound microscope. So this is the whole thing that works, and capital D is the distance of the image from the eyepiece, and then F0 is the focal length of the objective lens, Fe is the focal length of the eyepiece, H prime is the height of the image formed by the objective lens, U is the object's distance. U is the object's distance. Okay, so with this we are going to take it forward. So here what I would like to conclude is, I am going to tell you how the magnification really happens, because this is a very simple optical instrument which we have seen many times in our day-to-day life, and we are just going to show you how the magnification is actually calculated for this. This is nothing but L. L is nothing but the length of the microscope. You would have seen the length of the tube that will move down and up in order to focus the slide that you keep underneath that. That length of the microscope L should definitely be greater than F0 and Fe. Only if your L is greater than F naught and Fe, you will be able to move it up and down, and you can accordingly focus the slide underneath it. Okay, so these are few very important things that will happen inside a compound microscope. So now to begin with, I am going to calculate the magnification produced by the compound microscope. Okay, magnification produced by the compound microscope, where small m is equal to h prime by h it is. The magnification small m is equal to h prime by h it is. So that is what I am going to find. This is h prime and this is h. This is beta that I have marked in. So now tan beta is equal to opposite by adjacent. You see, first I will take this beta over here, which is h. So tan beta is equal to h by f naught, and again in this triangle tan beta is equal to h prime by L, So using this, I will replace the above equation as h by f naught is equal to h prime by L, which is equivalent to h prime by h is equal to L by f naught, So this is the amount of magnification that is being produced by the objective lens. That's why I just call this to be MO. I'll just call it to be MO, which indicates the magnification produced by the objective lens. So now coming to the eyepiece. So I will be treating the eyepiece just like a simple microscope. So we have already discussed about the magnification produced in the simple microscope. There are two types of magnification. One is the near point magnification and the other one is the normal magnification. So the first near point or near point focus is already defined as 1 plus ME stands for the magnification produced by the eyepiece, where ME is equal to 1 plus D by F it is. This is for the near point, and for the normal focus it is D by F. For normal focus it is D by F. Okay. So this is for the second lens, which is your eyepiece. Okay. This magnification M naught is for the first lens, the objective lens. So the overall magnification, the total magnification is given as capital M is equal to M naught into ME it is, M naught into ME it is, which is equal to what is M naught over here? It is L by F naught. It is L by F naught. L by F naught into ME is nothing but 1 plus D by F for the normal, near point. Near point means you are seeing an object which is very close, which means how close it is? It is closer, like something close to 25 centimeters. Okay. So if it is for the normal focus, L by F naught into d by f it is, d by f it is. So, this is the total magnification that is being produced by your compound microscope. So, this is a very important formula that everybody should actually remember, or if at least you try to remember this, where there have been many complicated numerical questions have been asked depending on this particular formula in the previous years, okay, both in CBSE examination and in the NEET examination. So, be very careful about remembering the magnification of the compound microscope. So, with this we come to the end of this session. We will again meet in the next session with a different set of topic. Thank you.